Hi, Assalamualaikum. My name is Amzar Syafiq bin Ahmed SHUKRI. Today I will present to you about my final year project presentation, which entitled Motorcycle Friendly Roadside Barrier. This project is a collaboration between UITM and Malaysia Institute of Road Safety and Research, which is known as MIROS, and my supervisor is Dr. Muhammad AZMAN YAHAYA. Okay, firstly I will start with the introduction. Okay, most motorcycle used in Malaysia, like other Asian countries, they are very common, and they uses the W beam guardrail as the safety roadside barrier. What is a safety roadside barrier? Okay, I will tell you. A safety roadside barrier is a guardrail that is consists of a steel beam fixed to the post, which has a W shape and 2 meter and 4 meter interval, post embedded to the soil. Okay, for the next one is what is the problem statement of this research. As you all know, the W beam guardrail is initially designed for the truck and car, but not for the motorcycle. Under the guardrail, the motorcycle can hit the post or can slip through. Research has shown that motorcycle collision with the current W beam guardrail has an severe impact collision with the motorcyclist. I will show you in the next video. Every problem has the solution. So, how to solve this problem? Okay, it is known as the motorcycle barrier attenuator, or known as the MBA. It's a polyethylene barrier structure designed to protect from the collision. Okay, how it works is by the attenuator absorbs energy and redirects the impacting motorcyclist in order to decrease the accidents and the fatalities among the motorcyclists. Okay, next one is for the MBA installation. The installation of MBA is very easy and very fast because it can attach with the existing current W beam guardrail, which only needs a 4 team of people and requires only a flat surface type. Everything has room for improvisation and innovation that can be done. So what can we improve on the current MBA design? So there are currently 2 things that we can improve the current MBA design. The first one is the bolster barrier, or known as a bowler. What is a bowler? Bowler is an impact system that will be attached to the MBA. Sand will be put into the bowler because it has a high impact absorber, which means will decrease the impact of the crashes. Okay, the second innovation that has been made to the MBA is the glow in the dark features. In order to increase the motorcyclist vision, especially during the night time. Glow in the dark can be added by the process of injection molding, by inserting the luminance into the MBA. The more luminance you put, the brighter it will looks, and will increase the vision of the motorcyclist during the night time. Okay, so every research has its own objective to be achieved. So, what is the research objective of this research? Okay, there are currently 3 things that need to be achieved of this research. The first one is to study the efficiency of the MBA in order to decrease the injury among the motorcyclists. The second one is to suggest on the current improvement design on the MBA. And the third one is to increase the energy absorption in the MBA. Okay, next one we will proceed to the methodology. Okay, for the methodology, from the left side, you can see the flowchart of the methodology of this research. The simulation will be done by using NC software, which helmet will be used in this simulation because most of the time the motorcyclist wearing the helmet during the crash. Okay, the simulation will consist of two types. The first one will be the helmet against the motorcycle barrier attenuator. The second one will be helmet against the steel post, which includes three types of helmet orientation, which is frontal, upper and back at three different speed level, which is low 30 km per hour, medium 50 km per hour, and high 90 km per hour. Okay, so I will present to you the detail of the methodology. Okay, for the first one, we will create the explicit dynamic files in the NC software. The second step is to insert the material definition. We will insert the real or exact material used in the crash to obtain the accurate result. As you can see from the table, we will have the Young modulus, density, Poisson ratio, shear modulus, tensile strength, ultimate shear strength. For example, we have four types of material: the ABS for the helmet, the structural steel for the steel post, the polyethylene for the MBA, and the sand is for the boiler. Okay, the third step is the 3D geometry import from CATIA. Okay, as you can see, the first two is the frontal helmet orientation against MBA and steel post, and the second is the upper orientation of the helmet against the MBA and the steel post, and the final is the back helmet against the MBA and the steel post. The geometry is drawn by using CATIA and will be imported to the NCs. Okay, the next one is by applying the velocity. We use the three velocity, which is low, medium, and high, and has three helmet orientation, which were frontal, upper, and back. As you can see, we will use the x direction of the velocity applied to the 3D model. This is the example of we put the 25 meter per second or 90 km per hour into the velocity. Okay, the fifth one is by applying the fixed point and displacement. So for the fixed point, we will apply to the MBA and steel post 3D model to make sure the 3D model does not move in any direction. The sixth one is we run the solution by inserting the von Mises stress. Okay, next one is the energy summary. So what is energy summary? Energy summary is a relationship between internal energy and the kinetic energy of the helmet during the crash. Okay, the last one we will proceed with the post-processing, which we will turn on the animation in the simulation to investigate the structural behavior of the von Mises stress of the helmet. So result, we will proceed with the result because result is the most important things during conducting a research. Okay, so what is von Mises stress? Von Mises stress is frequently used to identify the design failure because it will determine the structure's load capacity in relation to the real loads. Okay, we will proceed with the frontal orientation of the helmet crash. As you can see in this picture, the helmet will be deformed when hitting the both MBA and the steel post. So from the simulation we can obtain the von Mises versus time graph. As you can see, there are three different graphs. The first one, so in the y-axis we will put the von Mises stress in unit Pascal, the x-axis in time, unit second. As you can see, the red one is represent steel post and the blue one represents the barrier attenuator. So as you can see, the red one or the steel post is higher in the 30 km per hour, same as in the 50 km per hour, and also same as with the 90 km per hour. Okay, next one we'll proceed with the upper orientation of the helmet crash. As you can see, both helmet will be deformed against the MBA and the steel post, and the von Mises stress versus time graph also shown that the orange one will be the steel post, which is higher than the blue one for the motorcycle barrier attenuator. For all the graph, 30 km per hour, 50 km per hour, and 90 km per hour. Okay, for the last one, we will proceed with the back helmet crash, which shown the deformation. And for the von Mises stress versus time graph, also shown the steel post deformation of von Mises stress is higher compared to the blue one, which is the MBA. As you can see, in the 30 km per hour, 50 km per hour, and 90 km per hour. What we can conclude is the higher the velocity, the more the deformation or the von Mises stress of the helmet will be. So the most important is the energy summary, because energy summary will determine the result that we obtain during the simulation is correct and accurate. Okay, so the purple one is the internal energy. Internal energy will increase when crash happens and will decrease when the when the helmet bounce back. Okay, the kinetic energy is the helmet will decrease when crash happens and will increase when the helmet bounce back. Okay, so what is the impact of this research to the society or to the world? Okay, so the impact of this research is from the NC simulation that have been done. All the graph shows that the von Mises stress is low when the motorcyclist hitting the MBA compared to the steel post because of the impact of the energy absorption, and the force is spread to the wider area. Therefore, the MBA implementation in Malaysia is a very crucial to be implemented. Okay, next we will proceed to the conclusion of this research. So what can we conclude? So the paper presents the frontal upper back helmet crash, which is in 3 different speeds, which is low, medium, and high. By using the helmet crash against the MBA and the helmet against the steel post. Based on the graph, every graph, as you can see, the helmet experiences more impact when hitting the steel post. Okay, hence this proof the objective of this research were achieved. Okay, so lastly, for the recommendation. So there is one recommendation that is recommended for the future research. For now, there is a limitation of the software. So for the future research, we can use a human dummy model, or known as THUMS, the Total Human Model for Safety, which is a human dummy model that will demonstrates the human body kinematics and the injury relations during the crash in order to obtain more accurate results compared to the ANSYS. Thank you to all panelists for watching my full presentation video. Please do contact me at email amzarsyafiq.as@gmail.com, and my phone number is 0131479867 if there is any question or inquiry about my presentation.